This week's video is filmed by both me, May, and Shelli. Hope you enjoy!
Hi everyone, welcome back to another week of STEMpower. Today we will be learning about chemistry.
The fun fact of the week is that glass is not actually a solid. It is what's called an amorphous solid. The molecules in glass flow very, very slowly, so slowly that you can't really see it. Because of this, you think it's a solid, but it's actually not. It's between the states of a liquid and a solid. Chemists call this an amorphous solid.
Today we will have two activities, balancing equations with Legos and cleaning pennies. For the first activity, we will be balancing equations with Legos. You will need Lego blocks, a printout of a table with colored Legos that correspond with the type of atom, and markers to mark the color of the Lego on the table. Before we start, let's go over chemical reactions. Chemical reactions happen when certain atoms, compounds, or molecules combine and rearrange to form new ones. An atom is a single unit of an element such as oxygen. A compound is when multiple atoms of the same element are grouped together to form one group. One example is oxygen gas, which is two oxygen molecules together. Finally, a molecule is when atoms of different elements group together to form a new type of substance, such as water, which is made up of two hydrogen atoms and one oxygen atom. Each chemical equation has two sides, which are called the reactants and the products. The reactants are on the left because they react to get the products. Just like when you multiply numbers in math and the answer is called a product, the answer of reaction is called the product as well. The reactants and products can also swap sides, and the reaction still works. It's like 3 plus 2 is equal to 4 plus 1, because 4 plus 1 is equal to 3 plus 2 is still true, even if the numbers are on different sides. When a reaction happens, all of the reactants turn into the product. There are no atoms lost or created. Just like when you cook, all of the ingredients are mixed together to make the final dish. The ingredients may change form and may change shape, but they're still in your final product, just like in a reaction. This is called the law of conservation, and it shows that elements cannot be created or destroyed. They are all there even if they look different than before. First, you will gather into groups of two. Each group should decide on a different color for each kind of atom on the sheet. Color the rectangle directly to the right of the atom with the color of Lego they have available. Organize the chosen Legos into their own groups based on the color of the Legos. Each group of Legos should only be one color for that type of atom. Here, I chose red for carbon, green for oxygen, and blue for hydrogen, so I'm putting them all into their separate groups. Your instructor will now pick a volunteer to explain what the law of conservation of mass has to do with the Lego blocks. Let's balance our first equation. In the first problem, the letters stand for different types of elements. H stands for hydrogen, O stands for oxygen, and H2O stands for water, or the product of hydrogen and water. This 4 is a coefficient. It lets us know how many molecules there are. In this case, there are 4 hydrogen molecules. Now, find the reactant side and the product side. Remember that the reactants are made into the product. They pass through the reaction to make the end result. Solve the first problem for what the coefficient or number of H2O is. How many water molecules are made from 4 hydrogen and 2 oxygen? The 2 is a subscript. Notice how it is smaller than the number 4. This 2 lets us know how many atoms in a molecule there are. In this case, there are 2 atoms. However, there is also a 2 in front of the O. This means that there are 2 groups of 2 oxygen atoms. So, in total, there are 2 oxygen molecules, or 4 oxygen atoms. To repeat what we just learned, the subscript, or the small number, represents atoms. The coefficient represents molecules. When you are balancing chemical reactions, you can only change the coefficients. Changing the coefficients simply changes the amount of the chemical there is, while changing the subscript will change the chemical itself. Remember, no Legos or atoms can be added or lost when performing a reaction. All the Legos have to be used. Now take 4 Legos of the color you marked as hydrogen, which should have 2 holes, and 4 Legos of the color you marked as oxygen, which should have 8 holes. Focus on the left side of the equation and put your Legos into groups based on what is written. You should have 4 individual hydrogen atoms and 2 groups of 2 oxygen atoms together. After you have the first structures, students should organize the hydrogens and oxygens into the structure on the right. You should have 2 structures with 2 hydrogen atoms on either side of an oxygen atom each. Take the structures apart.
While you've been doing this activity, you may have noticed a mistake in this equation. Pause here and see if you can find it. The mistake is actually that we did the wrong coefficients. We said that there were 4 hydrogens and 2 O2 molecules, but you can see that this doesn't create an equal number of H2O molecules. If I have 4 hydrogens and 4 oxygen atoms because of the 2 sets of O2 molecules, then this does not create an even amount and actually only creates 2 water molecules with 2 oxygen left over, because in 1 water molecule I have 2 hydrogens and 1 oxygen. This just goes to show that it's super important to check your coefficients and make sure that your reaction can work forwards and backwards. I hope you enjoyed the rest of the activities. Carry on.
Awesome! You just balanced your first chemical equation. This is the second equation. Solve the second problem for the coefficients of C and O2. In the second problem, the letters stand for different types of elements. H stands for hydrogen, O stands for oxygen, and H2O stands for water, or the product of hydrogen and oxygen. O still stands for oxygen, but C stands for carbon. In this equation, we have the big compound first, which is CO. This larger compound is the reactant and needs to be broken apart to create 2 products. In the beginning, we have 4 atoms again, 2 carbon atoms and 2 oxygen atoms. In the products, the 2 oxygen atoms are bound together into one group to form a compound. In the beginning, all 4 are in a molecule, but in the end, they have broken apart. Take 4 of the carbon LEGOs and 4 of the oxygen LEGOs and put them in the reactant group. Make 2 carbon monoxides. After you have the compound, recreate the right side of the equation and see how many molecules there are for each. You should have 1 oxygen structure made of the 2 oxygen atoms and 2 carbon structures, each with 1 carbon atom. This is the third equation. Break this into groups of 4 to solve it. First, take 5 carbons, 12 hydrogens, and 16 oxygen, and set up LEGOs for the reactants. All 3 of these are the elements we discussed, but this is a new compound. We have provided all but 1 coefficient, so all you need to find now is the number of water molecules. Just remember to keep track of how many elements there are, and you can figure it out. After you have tried to find the number of water atoms, see how you did. You should have 6 water atoms. The first discussion question is, what is the most important rule of balancing equations called? What does it mean? The law of conservation of mass, developed by Antoine Lavoisier in 1789, states that during a chemical reaction, matter is neither created nor destroyed. This means that if you start a reaction with a certain number of atoms, you cannot create or destroy atoms. So, in the final product, you will have the same number of atoms. All that happens during reactions is that the original atoms, compounds, or molecules rearrange to form different ones. For example, when you bake cupcakes, you might use eggs, milk, flour, and many other ingredients. These are all your reactants. When you finish baking, your product is a cupcake that still has all of the original ingredients, just in a different and very delicious form. None of the products are lost, and no products are gained through the process. The second discussion question is that if we were to make 6 water compounds, how many oxygens and hydrogens would we need? How could you set it up? 3 O2 and 12 H's. The equation would be 12 hydrogen plus 2 oxygen is equal to 6 H2O. Because there are 6 water compounds, we know that you need 2 hydrogens per each and multiply 2 hydrogens by 6 compounds. But for the oxygen, we need to keep oxygen with another oxygen, also known as oxygen gas, because it cannot be alone. So, we know that we need 6 oxygen atoms in total, and since they must be together, we know that we can have 3 compounds of oxygen gas. In the second activity, we will be cleaning pennies. You will need 2 dirty pennies per group, vinegar, cups, salt, dish soap, and water. You will now return to your groups of 2. Each group should have all the materials. Prepare 1 cup halfway filled with salt, about 1 teaspoon, and vinegar. The other cup should have water and dish soap, about half and half. Which solution do you think will clean the pennies better? Write it down and explain the reasoning behind your hypothesis. Now, put 1 penny in each solution and let it sit for 5 minutes. After 5 minutes, each group should take out and briefly rinse each penny with water. Then, compare the cleanliness of the 2 pennies. Discuss or write down what you think may have happened. The first discussion question is, if I put water and salt together, will they clean the penny? No, they won't. Vinegar cleans the penny, whereas water cannot because it does not contain the required elements. But the combination of salt and vinegar cleans the penny because if we looked at the equation, only together can they make the HCl, which is the cleaning agent for the pennies. The second discussion question is, summarize the penny lab and what you've learned. The penny lab taught more complex equations and how chemistry can be applied to real life. Chemistry is all around us, and equations can be applied to any situation because there are so many chemical reactions. Further, we briefly overviewed the scientific process and showed you how to go through the process of making a hypothesis, testing it, and comparing results. I hope you enjoyed the activities and learned something new about chemistry. See you next week. Bye!